Hello. Today I'll be explaining to you how to solve number 20 in Energizing Physics, lesson 3.3. So, in number 20, you're given that two groups want to solve how far they have to pull back a slingshot in order to reach a displacement of 9 meters. However, the two groups calculate their displacement slightly differently. Group A calculates their displacement from the point where the box is released to the end, and that's 9 meters, while Group B calculates their displacement only starting from the end of the slingshot. And so you're given that the total displacement is equal to 9.00 meters, the K of the cord is equal to 20.0 newtons per meter, and the force of friction is equal to 0.150 newtons. And in both cases, you're trying to find x. And so the important concepts to keep in mind are that the energy at point 1 plus work is equal to the energy at point 2. That work is equal to force times displacement, and that EPE is equal to 1/2 kx squared. And so, solving for A first, we're given that the KE at point 1 and point 2 are 0, because at both points the box is at rest. So at point 1, there's only EPE. And the work that's added to it by work friction causes the energy to reach 0. And so, plugging some of the formulas, we get that 1/2 kx squared plus force times displacement is equal to 0. And plugging in the variables that we were given, we get that 1/2 times 20 x squared plus 9 times negative 0.15 is equal to 0. And so the force of friction is negative because although the box travels this way, force of friction is trying to slow it down and make it go the other way. And so as a result, the work done by friction will be negative. And so simplifying this a bit, we get 10x squared plus negative 1.35 is equal to 0. 10x squared is equal to 1.35. X squared is equal to 0.135. And x is equal to 0.367 meters. And so that's the stretch that you need to solve for Group A. That's the stretch that Group A needs to pull their slingshot back. However, for Group B, they start their displacement at the end of the slingshot, which means that the x is not calculated. However, force of friction still applies in between where the slingshot is released and the end of the slingshot. And so the work done by that will be 0.15 times x. And so, plugging back in the equations, we got that EPE plus work equals 0. 1/2 kx squared plus F times D equals 0. Right? And so, EPE stays the same, but work changes. So, the box still travels 9 meters, but it also travels x meters. And during that x meters, the force of friction also applies. So x needs to be added there. And so simplifying this a bit, get 10x squared minus 0.15 x minus 1.35 is equal to 0. And so plugging this into the quadratic equation, we get x is equal to 0.375 meters. And these answers make sense because in order for a box to stretch that far, to be shot that far from the slingshot, they need to be stretched a decent amount. However, Group B slingshot has to be stretched even more because their force of friction also is applied over the stretch, and also over the 9 meters instead of just the 9 meters in Group A. And so as a result, the work of friction will be slightly greater. And so in order to overcome that, the stretch will, as a result, need to be greater in Group B than it will be in Group A.